right, let's take a look at the Unit 3 practice test. For every problem, I'm going to pause for just a moment to give you a chance to pause the recording and test yourself before I go over it with you. So here's number one, graph both functions to find the solution or solutions to the system. So let's start with f of x. That is a linear function. We know the constant is the y-intercept, slope-intercept form, right? So first thing, we plot that y-intercept. Boom, -2. Slope of 2, we use that slope to plot another point. Up 2, right 1, boom, 2 points. Connect the dots, you have your linear function f of x. That's the orange line. Not too difficult, right? Something you've done before. Now it's time for g of x. Quadratic, leading coefficient of 1. So let's start with the y-intercept. Again, that's the constant. Boom, -3 right there. And we really would like to find the vertex because that helps us get a good idea of where everything is. Of course, you could plug in different x values to find it eventually, but this is a quick and efficient way. Remember to find the x value of the vertex. It's this little formula right here. So we take B, we take A. Plug them in, we get -1. Plug that back into your function to find the y value of the vertex. Square it, multiply it, add and subtract, and we get -4. So vertex there at -1, -4, which is not just the vertex, but it's also one of our solutions. Now at this point, we would have our orange line graphed. We have our vertex, and we know this line is going to go up and to the left and up and to the right, but we want to know specifically where it's going to intersect with the orange line because that's our solution to the system. Okay, so you might pick 0 or 1 or 2, and you will find that 1 lands right there. So we plug in 1, we get 1 squared 1, 2 times 1, add and subtract, we get 0. 1, 0 is our second solution. Now, if you wanted to find your x-intercepts, you could have also factored this and then set each factor equal to 0, solve for x, and you could find it that way. I found this way to be a little bit simpler. Number 2, very similar. Again, we have a linear function and a quadratic. The only difference is it's negative. Okay, so we graph our straight line first, y-intercept of 2. Right there, boom. Slope of 1, right? Coefficient of x is 1, 1 over 1. So rise 1, run 1. Orange line, that's f of x. And our quadratic. If you're familiar with the parent function, you could, instead of showing all of this work to find the vertex, you could say, I know that the parent function has the vertex at 0, 0, and I know 4 is elevator V, meaning every point moves up 4, and I know the negative means the quadratic, the parabola, flips upside down. Okay, if you're super familiar, but of course then you need your other points. But if you're not super familiar with that, do the same thing we did on the last problem. Y-intercept is the constant. Okay, 4, boom, there it is. And the vertex, x of v, use the same formula, work it out. Numerator is 0, so 0. Plug in 0 into the function, you get 4. 0, 4 is the vertex right there. Of course, we need to find where these intersect. So again, you're picking x values nearby, like 1, -1, 2, -2, and you'll find that 1 and -2 give you those two solutions. Okay, well, we've looked at two problems that have a straight line and a parabola, and both of them had two solutions. Is that always the case? No, right? We learned before. Of course, there can be two solutions, but there can also be one solution if it just touches and turns around, or no solutions if they don't touch at all. Number three, we're determining if the function is even, odd, or neither based on a graph. No written function, just the graph. How do you know? Well, this function is odd because it has origin symmetry. Remember, origin symmetry means you flip it over the y-axis, then the x-axis, or vice versa. It doesn't matter which order you do that in, but it needs to lie back down on itself to be odd. And that's exactly what would happen. The blue line here is the original line we see. And I went ahead and I flipped it first over the y-axis. So this goes there, this moves there, right? This moves there, this moves there. Everything flips over that y-axis. And then you can visualize if we flip it all over the x-axis, this orange line that is, this will go there, this will go there, and you get the idea. It will lie right back down on top of the blue line where we started. But I would recommend you write down all three of these so you're familiar. Even means y-axis symmetry. So if we had a graph, it would look something like maybe this. Looks the same on the left and right of the y-axis. And if neither of those things are happening, it's neither. Number four, identify the relative minimum and relative maximum values over the interval -2, 2. What does over the interval mean? Well, it means between the x values of -2 and 2. Maybe drawing dashed lines like I am will help you. So we're asked to find the relative min. Well, relative min is the lowest point between those x values, and we see that right here. And we really only care about the y, which is -3. So that's our min. And then, of course, the max is up here. Again, only caring about the y value. The max is +3. You identified if a function was even, odd, or neither from a graph, but do you remember how to do it with a function? Here's my clue. It's all about the exponents. If you said odd, you are 100% correct. It's all about the exponents. If all of them are odd, the function's odd. If all are even, it's even. And if there's a mixture, then it's neither. Like, for example, if you had this function where you had an odd power and then let's say, let's do plus x squared. Well, here is odd, here is even. That would be neither. That's not our situation, but just an example. And number six, we're given a graph We're told it models the height of a roller coaster in its first 10 seconds of operation. So we see that here from 0 seconds all the way to 10, which is our entire graph here. And we're being asked to select each correct answer. Read through them one by one, show some work, explain if you'd like, and find the correct answers. Okay, let's do it. A height of 26 meters was hit 3 times. Let's see, 26 meters, that's a height right here. And how many times did our graph line, which is our roller coaster, hit it? So it went up, boom, hits once, goes up, and then we go down, boom, hits again, down and up, boom. There's a third time. That is correct. B, the roller coaster started at a height of approximately 8 meters. Well, it started at 0 seconds, didn't it? So we're really looking at the y-intercept right there, and I'm going to label that as the starting point. Maybe also label it with the y-intercept. And that is not true, right? We started at 4 meters, not 8. C, the height of the roller coaster increased over the first 2 seconds. Okay, so what happened? We go up and up and up and up. 2 seconds stops there. Yeah, we only traveled in a positive direction. True. D, the end behavior is the same on both ends of the graph. End behavior is what's happening at the end of the line. Here we have an arrow going down that way, and here an arrow up this way. Are they going in the same directions? Clearly not. This one is going up and to the right, and this one's going down and to the left. And finally, the height of the roller coaster decreased between 7 seconds and 9 seconds. Here's 7, here's 9 seconds. Let's see what happened. Increase, 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 stop. That is an increase, not a decrease. Also incorrect. All right. Well, those are the first 6 problems of our practice test. Come back to the next lesson to get the last 6.